Hi, everybody. Welcome to our controls project presentation. Today, we're talking about what we did, which is controlling the temperature inside of an oven. So to begin, just to explain and lay out what our goals were for the project in general, we were to have hands-on experience planning, developing and troubleshooting a PID controller. And then for our particular project, we wanted to control the temperature of a somewhat jerry-rigged convection oven. What we really wanted to focus on when it came to our controller was that there was minimum oscillation and that it meets the temperature set points that we set. So for our apparatus, we had some styrofoam as our insulation and then had our heater at the bottom with a fan blowing directly on it from the top. For our heater, we used the TC Lab and then used the ESP32 microcontroller for our controller. We then had a thermistor on the TC Lab measuring the temperature and then a computer fan that was blowing directly on top of it to regulate the temperature.
So the theory behind our models, we used a energy balance. As you can see, we have both convection and radiative heat transfer occurring within our system, and as well as the heater providing energy as the last term in our physical model. And so to tune our controller and our model, we use the aggressive tuning, the IMC aggressive tuning. And so with that and performing a step test, we were able to get our FOPDT parameters, as you can see here on the left, our KP, our tau P, and our theta P. With our KP, it was negative 0.16 degrees Celsius per percent of fan speed. And with our tau P, it was 39 seconds. And as you can see with the theta P, we did not observe any visible dead time, so that made it easier with our tuning, as that is 0 seconds. And using our PID parameters over to the right, with a KD of 0, it took out the derivative term, which simplified our PID controller to a PI controller. And here are the results of our step test. As you can see, the red dots visualize the actual data taken by our thermistor. And the dotted line is the predicted value from our physical model using calculated parameters from estimating and fitting to the measured data. And below is just the step test from a 40% fan speed all the way to 100% fan speed for around 4 or 5 minutes.
So once we had those FOPDT parameters, and as Griffin said, converted them over to PID parameters, we were able to use those in a controller in order to control the temperature of our convection oven. We first ramped up the TC Lab for a couple minutes beforehand in order to increase the temperature, and then once we started our controller, the temperature was able to decrease first to our set point of 40 degrees, and then gradually start to approach our set point of 30 degrees after about 3.5 minutes. As far as stability goes, we manually tuned the parameters a little bit in order to reduce the oscillation, and it was able to reduce it a little bit, as is shown in this graph. So in this lab, or in this project, our fan actuator system demonstrated fairly good temperature stability. The tuning of the PID parameters resulted in less oscillation overall, and overall better set point tracking. A couple of the limitations that we found in this project were that our fan couldn't run with less than 40% of the capacity being supplied to it. So that was something that we could possibly show in future endeavors, as well as different types of fans and different types of materials. Thank you so much. And this has been our convection oven lab with Griffin, Zach, and Xander.